Hello students, I welcome you all once again. Today in this video, I am going to explain acidity of alpha hydrogens which comes under active methylene compounds. The name of the chapter is active methylene compounds, and in some textbooks you can also find it under organic synthesis based on carbon ions. So both are same students. So today especially I am going to teach you what is this acidity of alpha hydrogens. So before going into acidity of alpha hydrogens, I would like to tell you what a carbon ion is. Okay, so the name of the lesson I have written active methylene compounds, students. So under this we have a little introduction, that is the definition of carbon ion. What is a carbon ion? So you all must be knowing that a carbon ion means a carbon atom bearing negative charge. Right, you are absolutely 100% correct. So how do we define a carbon ion? The ions which contain, especially the organic ions which contain a negatively charged carbon, we call them as carbon ions. And how are they formed, students? They are formed by heterolytic bond fission. So I have given here the definition. If you want, please take a book, a notebook and a pen and kindly note down the definition, students. Put the heading active methylene compounds, under which we have the definition of carbon ions. Can you see, students? The organic ions which contain a negatively charged carbon are called as carbon ions. Hope I am clear. And these carbon ions, they are formed by heterolytic bond fission. Look here, I have written heterolytic bond fission. Clear? Now, so here you can see below, I have taken a compound like this, carbon with the 3 bonds. Generally carbon has 4 bonds, right? Its valency is 4, and I have mentioned here one atom as Z. So this is also a bond. The bond meaning is 2 electrons present between carbon and this atom. So after heterolytic fission, what happens? These 2 electrons are taken up by this carbon, by which carbon gets or carbon acquires negative charge, and this Z, this atom acquires positive charge. Okay. Now this is called as carbon ion, which I have mentioned here. Fine. Now in this Z, if you see, when compared to carbon, it is less electronegative than carbon. Okay, students. So this is what we call it as heterolytic fission. This is not homolytic fission. Homolytic means 1 electron taken up by carbon, 1 electron taken up by Z. No, here the 2 electrons are taken up by carbon. That's what we call it as heterolytic bond fission. Okay, now this is carbon ion, carbon bearing negative charge. Hope I made it clear. Next. Now moving on to acidity of alpha hydrogen. So first you should know which hydrogen atom we call it as alpha hydrogen. So hydrogen, look here students, I have mentioned an example here. CH3, C double bond O, CH2, CH3. How many carbons are there? Total 4 carbons are there, and this is carbonyl group we call it as. See, I have marked here C double bond O group, we call it as carbonyl group. Fine. Now this carbon and this carbon are the adjacent carbon atoms to this carbonyl group. Immediately next to this carbon, next to this carbon is this carbon. Now this is not the adjacent carbon, students. Okay. Now how many hydrogens are here? 2 hydrogens. How many hydrogens are here? 3. Now these hydrogen atoms, we call them as alpha hydrogens. These hydrogens, we call them as alpha hydrogens. Now how do you define alpha hydrogens? The hydrogen atoms which are present on the carbon atom adjacent to carbonyl group, immediate next to carbonyl group. Such hydrogens we call them as alpha hydrogens, and their nature is acidic. Okay, so look here, next put the side heading, students. Acidity of alpha hydrogen. So write down the definition I have written here. Carefully follow ma. The hydrogen atoms present on the carbon adjacent to a carbonyl group are called as alpha hydrogens, and they are acidic in nature. Okay, so please write down the example here. Okay, now so you understood what an alpha hydrogen is. Fine. Now these alpha hydrogens, they can be easily removed. Okay. So how they can easily be removed? With the help of a strong base. For example, sodium ethoxide. Okay, so when this compound is treated with sodium ethoxide, the hydrogens which are present on this carbon adjacent to carbonyl group. So we need not now tell this long. We can directly say that alpha hydrogens in this compound can be removed in the presence of a base called as sodium ethoxide. Do you know the formula of sodium ethoxide, students? It is NaOC2H5 or C2H5ONa. So this alpha hydrogen, when it is removed, immediately carbon ion will be formed, and that carbon ion, it is stabilized by resonance. Okay, so look here, alpha hydrogen from the above compound. What is the above compound? This is the above compound. Can be easily removed. By means of a strong base, like sodium ethoxide. Formula NaOC2H5, students. Now, once the alpha hydrogen is removed, what will be formed? Carbon. That also I will show you. The carbon ion thus formed, will be stabilized by resonance. The carbon ion formed after the removal of hydrogen atom is stabilized by resonance. So how it is being stabilized, I will show you. Kindly pay attention. So now below this paragraph, write down the above compound, students. What is the above compound? CH3, C double bond O, CH2, CH3. So what I did here, one of the alpha hydrogens I have shown separately here. CH3, C double bond O, CH2 I did not write. One hydrogen I have written separately, CH3. Now from NaOC2H5, ethoxide ion, what it does? So this compound is treated with sodium ethoxide, students. So this OC2H5, this is called as ethoxide ion. This ethoxide ion, it takes up, see, carefully write down. This OC2H5, it takes up the alpha hydrogen, and this H is coming as H plus, students. So H plus OC2H5 minus goes out as C2H5OH. I am writing here C2H5OH minus, you write down. Okay. Next. Now these electrons, the electrons present between carbon and hydrogen, they are shifted between carbon and carbon. Next, this pi bond moves towards oxygen atom. Clear? Okay. Now CH3, C double bond O, CH2, CH. This compound, when it is treated with sodium ethoxide, OC2H5 minus, that is the ethoxide ion, abstracts this alpha hydrogen. So H is coming out as H plus. So OC2H5 minus plus H plus goes out as ethyl alcohol. Next, these two electrons moving here and these 5 electrons moving towards oxygen. Next, what happens? Carefully write down CH3, next C, here comes O minus, next double bond CH, CH3. Okay, CH3, CO minus, double bond CH, CH3. Fine. Now what happens? This negative charge moves moves in between carbon and oxygen. Again, double bond will be formed, and this double bond, so this bond moves towards carbon. Hence, this carbon acquires a negative charge. Next, put an arrow, students. CH3, C, double bond O, CH. Okay, now here comes minus CH3. Okay, so this is the carbon ion. Okay, so this is the carbon ion, students. Now this is stabilized by resonance. So what you do here, you write down the arrow like this. Okay, so this will be sometimes like this, or sometimes it will be changing like this. Fine. So this is the carbon ion, students. Got it? Clear? So again, alpha hydrogen is the hydrogen atom which is present on the carbon adjacent, or which is directly attached to the carbonyl group. So we have taken this example and how the alpha hydrogen can be removed in the presence of sodium ethoxide and how a carbon ion is being formed, we have seen. Okay, students, clear? Next, when a methylene group, what is methylene group, students? Which group we call a methylene group? CH2 group is methylene group. When this methylene group is present in between two carbonyl groups, you know what a carbonyl group is, C double bond O, right? Then the hydrogens of this methylene group can be easily removed in the presence of a base without using any external factors or any sort of energy. Okay, again I will show you what I have written. When a methylene group CH2 is present in between two carbonyl groups, then the hydrogens of methylene carbon. So the hydrogens of the methylene, this is the methylene carbon, hydrogens of the methylene carbon can be removed easily in the presence of a base without using any sort of energy. Okay, so I will show you an example here. CH3, C double bond O, CH2. One hydrogen I have written separately. C double bond O, O C2H5. See, this is the methylene group. Just we will mark it. Okay, CH2 group present between two C double bond O groups. These two are carbonyl group, students. So this is the methylene group. The hydrogens present on this methylene carbon can be removed easily without using any external factors or any sort of energy. So in the presence of a base. So again we have taken sodium ethoxide. This is the ethoxide ion. Now OC2H5 minus abstracts the hydrogen which is present on the methylene carbon. So draw the arrow carefully. Fine. Don't touch this bond. So H is going out as H plus. So what happens again? We know that it comes out as minus C2H5OH. Next, what happens when this H is going out as H plus? Now this bond moves to in between these two carbons. Okay. Next, this bond will be shifted towards oxygen. So by which oxygen acquires negative charge. Here forms a double bond, and now this hydrogen is not there on this carbon. So this is now going with the OC2H5 minus, coming out as C2H5OH. So next, what to write? CH3, write down students. Next, C O minus, double bond. So one H is not there, only one H, CH, C double bond O, O, C2H5. I will show you. CH3, CO minus, double bond, CH, C double bond O, O, C2H5. Next, now we will show the formation of the carbon ion. Same like the previous example, this minus moves in between carbon and oxygen. So again a double bond is formed. Now this bond moves towards carbon, by which C gets negative charge, and that is the carbon ion. Fine. Next. So I will show here CH3, C double bond O, CH minus, C double bond O, O, C2H5. Okay. CH3, C double bond O, CH minus, C double bond O, O, C2H5. So this is how the carbon ion is being formed, students. So mention here below carbon ion. Okay, so the carbon ion thus formed is stabilized by resonance. So we will be showing with this kind of arrow. Understood now? So how a methylene group which is present in between two carbonyl groups, the hydrogen atoms can be removed in the presence of a base. So you can easily show how this hydrogen present on the methylene carbon is removed in the presence of a base like this. Okay, noted down, students. Completed writing. So students, the methylene group which is present in between two carbonyl groups, how the carbon ion is being formed with the help of sodium methoxide, just now we have seen. And students, such a methylene group which is present in between two carbonyl groups, they are highly electronegative. So in general we can say like this: a methylene group present in between two electronegative groups or atoms, we call it as active methylene group. Okay, so you have to underline this sentence, ma. The methylene group which is present in between two electronegative groups or atoms is called as active methylene group. Okay, now the same example which we have mentioned here, you can note down. Example: CH3, C double bond O, CH2, C double bond O, C2H5. Its name is acetoacetic ester. Okay, so I have marked here. Look here. This is the methylene group present between two carbonyl. These are the two electronegative groups, and this is called as active methylene group. And one more example also is there, students. That is malonic ester. OC2H5, C double bond O, CH2, C double bond O, OC2H5, which is called as malonic ester. So mark here also the active methylene group, students, CH2 present between two carbonyl groups. This is called as malonic ester. Fine. So these two examples you can note down under active methylene group. So hope you understood acidity of alpha hydrogen, students, and please if you did not write, you kindly write down in your notebook, and you can prepare this for your exam also, which helps you a lot. And students, those who are watching for the first time, please don't forget to subscribe, like, share and comment. Share with your friends, and meet you in the next video with another interesting topic. Take care, students.